All right, this part of geometry is like a really, really like famous part, I guess, if you want to call it that, of geometry. And the things we're going to learn here are things that when you think of geometry, you'll probably think of. All right, and this right here, see this SAS and ASA? We're going to talk about it in a second. Now, just a wild guess. It shouldn't be too wild, all right? What do you think the S stands for? The sides, and what do you think the angle? Exactly right, okay? And they're congruence postulates. So let's talk about postulate again. What does it mean to be a postulate? It's a statement that's what? That's true, but it can't be proven. That's right. Okay, you just accept it. You just accept it as truth, okay? Now, there is a way to demonstrate it. I'm not really going to do that today. They do this thing called constructions. And again, back in the day when I first started teaching geometry, we did constructions. Constructions are, oh my word, a compass. Little easy words, just I get lost sometimes. I'm getting older. Must be in dementia or something. I don't know. So anyway, a compass. You know what a compass is? It's that pointy thing, right? And part of the reason I quit having people do this because people would poke each other with the pointy compass and all that, and they couldn't control themselves. So that's part of the reason. But they're actually kind of fun. They're kind of interesting. But I just don't do them anymore. But what you can do is you can use a compass and a pencil, and you can actually demonstrate why these postulates are true. It's not really a proof. It's just a demonstration to show that it's true. This is one of those times where I'm just going to say, look, here it is. Just accept it. Okay, I'm not going to really show you exactly why. I think I do have another program that I could probably do that with. Haven't used it since last year, and I don't even know if I used it on this stuff. But maybe this weekend I'll go through that program and show you why this stuff is true. All right, it's not a proof of it, but it's why it's true. All right, let's talk about this. It's actually very simple. If you follow along, I'm just going to draw any old triangles, nothing special. Yeah, let's do it like this. Okay? And what I'm going to do is I'm going to copy and paste this. Actually, let's group it first and then copy and paste. And let's put this over here. And we'll keep them side by side just to make it look real easy. They're not always going to be side by side like this. But for right now, that's what we're going to do. And let's call this, let's see. Yeah, I'll just wing this. I didn't take notes on this, so we'll just wing it. So ABC, call this DEF. Okay. Now, remember what we had to know as of yesterday. Everybody listen? This is really important. Remember yesterday, what did we have to know in order to say that these two triangles are congruent to each other? We had to show what? We had to show all the angles equal to all the angles over here, correct? And what else? All the sides. So how many things is that we had to show in order to say? That's 6 things, right? It's 3 angles and 3 sides. Now today, this postulate, it cuts that number of things that you need to know in half. So you only have to know 3 things from this triangle and 3 things from this triangle over here. Okay? Here's what you have to know. If you know that, let's say, side AB was equal to DE, is that enough to know that these triangles are congruent to each other? No. All right? If you also know that this angle B and this angle E were equal to each other, that's not enough. Okay? Again, I wish I thought about practicing, because I really need to practice that program, because I'd just be winging it if I just brought it out right now and started using it. It is a cool program. We'll eventually get to it. But watch this. What if this side was also equal to this side? This postulate, and they call it, what do you think they call it? Side, angle, side postulate. Okay, let's write that down. So now it's SAS, but we don't usually say SAS. Okay, we usually just say side, angle, side. All right, so this is called the side, angle, side postulate. Today we're just doing postulates. Tomorrow we're going to do some theorems, okay, that you can prove. But these are, Well, you know what I mean. You know what I mean. You know I wasn't thinking we were going to come in here on Saturday. The next time we meet is we're going to talk about the theorems. So this one's called the side angle side postulate. Now, what do you, is it just any two sides and any angle? It's not. Look at the angle. The angle is in between these two equal sides right here. Everybody see that? So if I have two sides, if I have the angle that's in between those two sides, okay, and this side's equal to this one, this angle's equal to this, and this side's equal to this, then these triangles are now congruent. That's all you need to know. You don't have to know that AC and DF are equal. You don't have to know that angle A is equal to angle D. You don't have to know that angle C is equal to angle F. This is all you need to know. All right? So if you know that information, what can we say about those two triangles? They are what? They're congruent to each other. So let's write the congruent statement. So what are we going to call this right here? We could call it any of those three letters. It doesn't matter.
So they are congruent
if you have this side, this angle, and this side equal to this side, this angle, and this side.
So if you have two triangles with a side.
Yeah. Yeah, if you have two triangles and you have a side, you have we call this the included angle, the one that's between those two sides. All right, so this is called the included angle. The included. It means it's just between the included angle. It's between those two sides. Now these sides don't have to be equal to each other. Do you see that? This has got one arc, or this has got one tick mark. This has two. So these aren't necessarily equal to each other, but this one is equal to this one on the other triangle. This side is equal to this side of the other triangle. Okay? So let's write our congruent statement. So triangle, what do I want to call this thing right here? Yeah, you can call it a bunch of things. Let's just go ABC. Is that all right? Just makes it a little easier. So that triangle is congruent to this triangle right here, DEF, right? Remember what I said a little earlier today when I was going over the answers? What's one way to know which ones match up with each other? I'll tell you what, let's do something else before we get to that. Remind me to get to that, though, okay? It's pretty important. We're not eating in here. All right, so that's really important right there, okay? That these triangles are congruent to each other. So what does that mean then about angle A and angle D?
They're equal?
They're equal to each other. That's right. Because they are what? They do what? They correspond to each other. Exactly. Everybody see that? So angle A and angle D correspond to each other. If you look at it, we'll talk about it right now. Watch. I'll put two arcs. I'll put in a different color because the stuff that's in white, that's what they originally told us. Okay? So they told us that stuff in white. The stuff in color that I'm going to put is the stuff that we now know because those triangles are congruent. Okay? If those triangles are congruent to each other, then we know all the what? Corresponding parts of what? Remember, we wrote it on the board a few minutes ago. The corresponding parts of congruent what? Triangles are congruent to each other. All right? This right here, there's 3 C's in here, but what's that one? That's congruent, right? So what do you have to know first about those triangles? You got to know they're congruent. Are they congruent? Yeah. Why are they congruent? Because of side angle side postulate. Exactly right. Okay, that's what you would say. You wouldn't say SAS, you wouldn't say SAS, you just say side angle side, okay? So, why are they congruent? Side angle side. Why is angle A equal to angle D? Because of, exactly, because they're corresponding. Or what? What would be your reasoning? That the corresponding parts of congruent triangles are congruent, CPCTC, okay? That's your reason. Now, again, we're not going to do like formal proofs, but I am going to hit some stuff that we would do in proofs, and this is something that we would do in proofs. We have to be able to back up our statements with a reason, all right? And that's what we do. A formal proof looks like this. It's a 2-column proof, in high school anyway. It's a 2-column proof, and right here we put all the statements, all right? So we'll list a bunch of statements right here, and then this is going to be the reasons. So we give a reason for each statement, okay? So what would the reason that AB is equal to DE be? How do I know that AB and DE are equal to each other? Because what'd they tell us? Yeah, but why? Why is this side congruent to this? Because what? I can't hear. Yeah, they got the one line on it, but how did I know to put the one line on it? Because they what? They told me that those two sides are equal to each other. Okay? So the book told me. Or, you've seen this word before, it was what? It was given. That's right. It was given. All right? They told me that AB and DE were equal to each other. Why are they equal to each other? Talk to me. Because I just wrote it down. Come on, follow along, okay? I'm leading you, all right? Just follow me. That's all you got to do. I'm leading you along. So it's given. Why is BC equal to EF? It's given. Why is angle B equal to angle E? It's given. Why is angle A equal to angle D? Because they're corresponding parts, CPCTC. Everybody see that? Why are the triangles congruent to each other? Why? That's right. It's the side angle side postulate, okay? Zion, you like to know why, right? So that's what I'm doing. I'm giving you all these whys. Why are they true? All right? Why is all that stuff true? Well, all the stuff in white is true because they were given. This thing right here, A and D, or let's go back to the triangles. The triangles are congruent because of side angle side postulate. Angle A is equal to angle D because of what? Corresponding parts, right? CPCTC. What else do I know could be equal to each other? Angle C, right. Angle C and F, because why? Their corresponding parts are congruent triangles, right? So they must be congruent to each other. CPCTC. Everybody got that? And what else do you think is equal? Yeah, AC, so I'll put 3 there, and DF, I'll put 3 there. And why are they equal to each other? Because they're corresponding parts. Exactly. You get it? That's what a proof is. But the proof is you got to list all that stuff down. Okay, and you got to write it down. You got to write their reasons. But we basically, it's not really, I should say this. It's a proof on why angle A is equal to angle D. If I ask you to prove why angle A is equal to angle D, that's the proof. We didn't really prove the postulate because you can't prove postulates, okay? But we did prove why angle A is equal to angle D. We proved why angle C is equal to angle F. We also proved why line segment AC is equal to line segment DF. Okay? Now, aren't you glad we're not doing proofs? Yeah. We kind of did, though. We kind of did. All right? We thought them out. We talked them out. We just didn't write it out. That's all. Okay. So that is what? Side angle sides, not SAS. We never say SAS. We always say what? Side angle side. Okay? Side angle side. The next one? Yeah, what do you think the next one is? Angle side angle. So, tell you what, let's do this. Save me some time drawing different triangles. Now, what they're going to give you different stuff. They're not going to give you a side, an angle, and a side. What do you think they're going to give you? An angle. Oops. Come on, grab this thing. Grab it. Why can I not? There we go. It's so particular. All right. Let's call it something else. Give me some letters. YPC, BC, YBC. Give me 3 other letters that aren't the same as those. Give me your initials. What's your initials?
CWA.
Angela. What's your middle initial? G?
Yeah.
All right, and then M. All right, so there's your triangle. All right, so what do you think they give you? Because we're going to do, what postulate are we going to do? Angle side angle postulate. So they're not going to give you 2 sides. What are they going to give you? 2 angles. And what must be true about the side, though? It's got to be between the 2 angles, exactly. Everybody see that? All right, so angle side angle means they give you 2 angles. I could pick any 2 angles, it doesn't matter. Let's just pick this one. So we say this one is equal to this one right here. That's your one angle. And you could either pick that one up here or this one down here. Let's just pick this one down here. So you said that that angle is equal to that angle. How do I know that those are equal to each other? No, not yet. We don't know they're... It's given. Right, they tell us. Okay, Hunter, you watching? I don't think you're getting this. So these two this angles or angle Y is equal to angle A because they give it to you. They tell you. All right, it's given. Angle C is equal to angle M because it's given. Everybody got that? And they also tell you that side YC or line segment YC is congruent to line segment AM. Why? Because it's given. Good. So they give you all that stuff. Now remember, this is a postulate, so we can't really prove it, right? We just accept it as truth. So this postulate says, if I have two angles and an included side, right? So if two angles of this triangle and the included side are equal to what? Two angles of another triangle and its included side, then the triangles are what? Congruent. So what do you want to call this one? YBC. And then we're going to call this, if I go YBC, what am I going to have to do over here? AGM. All right? I keep saying I was going to do this. I'm going to finally do this. How do I know that the B and the BC corresponds to GM? Well, it just looks like it. This is on the right side. This is on the right side. Okay, you could say that. But what if we twisted it and flipped it? Then it wouldn't be that way, would it? Okay, sometimes it gets really confusing. So here's a way to make it less confusing. Do you see how side BC, what angle is side BC opposite? So side BC is opposite what angle? Angle Y, that's right. So come over here. What side is opposite the corresponding angle with Y? So Y and A are equal to each other, right? So what's opposite angle A? GM. So that's a good way to know that BC and GM are equal to each other. The way I've drawn it right here, and I didn't like flip anything, I didn't rotate anything, it made it really super easy. But if I flipped it and I rotated it or just flipped it, that's enough to make it confusing. How do I know which ones are corresponding to each other? Well, I was already told that Y and A are equal to each other. That must mean that B and C, or BC, is going to be equal to GM. Okay? Right now it's super easy, right? It's just the one that's slanted on the right, the one that's slanted on the right. But it's not always going to be that easy, all right? What about this side YB? What side over here is equal to YB? AG. And again, how do I know that? Well, you say, well, it looks like it's over here on the left-hand side. That one's on the left-hand side. Yeah, that's an easy way to look at it. But again, what if it was flipped or twisted or something like that? How would I know? YB is opposite what? Angle C, which has got the two arcs. Come over here. Here's the two arcs. What's opposite the angle with two arcs? AG. So this side is going to equal this side right here. Does that make sense? All right. It seems kind of easy the way it's written right now. But again, for about the 5th time today I've said this, if they flip it or twist it, all right, it's going to be a little more confusing. So what's true about B and G? They're going to be equal to each other. How do I know? Well, B is opposite this side with one tick mark, right? So what angle is opposite the side with one tick mark over here? The angle G. Everybody see that? So the B and the G go together. So B is opposite the one tick mark. G is opposite the one tick mark. Okay? That's really, and what's this got? 3? There we go. All right? So angle, side, angle. That's all you needed to know. You didn't have to know all 6 of them. All you needed to know is 3 of them. And that was it. Let's see. Let's take a look at your homework. You got your book open? Look at page 165. So what are we doing? 1 to 15? 20 to 23? And this is section 4.3. And what's the pages on there? 165, 166. 165, 166. So that's your homework. But let's just take it. We got a couple minutes here. Let's drop down to like number 7. Look at that. I'm not going to draw it on the YouTube. Tell you what, I'm going to close out the YouTube. We'll just look at the homework. All right, bye YouTube.